Hello everyone. So you have a good day. Welcome to this session on Kubernetes overview for developers. So I'm Priji.
I got graded out towards Kubernetes science university of projects. I'm not working now. I'm doing a new opportunity as well. Thank you.
So I work with a company called Max ID where we have Kubernetes used a lot, containerization and stuff like that. So what we're planning to cover is just an overview of the different Kubernetes objects and a few developer tools and an overview of various components in Kubernetes and a little bit of overview about extending Kubernetes and custom resources and operators. It's just a basic overview of these areas. Kubernetes was built at Google and they open sourced it in 2014. So it's a platform for managing containerized workloads. So if you can containerize your application, Kubernetes can run it. And in Kubernetes, we have a cluster of physical or virtual nodes. It can actually support up to 5,000 nodes and maybe 300,000 containers. That's kind of the limit. And it efficiently shares compute resources and it provides automatic bin packing, which we covered in the earlier session about scheduler, right? So you have these nodes and we specify what resource requirements we need for running our application, and Kubernetes takes care of an optimal scheduling to put your application on the right node and make use of the node to its maximum. So that is automatic bin packing. It supports stateless, stateful, and data processing applications. So once you have your component built as a container, right? So Kubernetes, we don't directly deploy that container, but we package that in a resource called a pod. So a pod provides an environment for the container to run. So it specifies the environment. Several other things that the container or our application needs to run. So this pod can pack actually multiple containers too. And in a pod, each container share a network namespace, which means these containers can communicate with each other using different inter-process communication mechanisms and shared volumes. So that makes it possible for us to package a coherent set of pods containers into a single pod. And again, we don't deploy pod directly, we can, but it's usually associated with a workload resource, such as a deployment. The workload is a Kubernetes application, and it has a controller associated with that, which ensures, for example, that the right number of replicas of the pod are running, and in case a pod fails, it restarts it. So some of the usually used workload resources are like deployment, which can actually do stateless services like a microservice or an HTTP host. A stateful set, which actually hosts stateful applications such as a database, a job that can do like a batch job, do and be done. Doesn't need to run forever. A daemon set, which actually runs on every node in a cluster. So once we have this pod, our application package and deployed as a pod, we expose the service or the functionality to a set of pods, right? And these pods, each one gets an IP address too. But if we consider deployment, which is stateless applications, and these deployments can have its pod restarted due to various reasons and have different IPs associated with that later on when it comes back, when the pod comes back. But if we want to access that service exposed by that pod through the pod and IP address, it exposes. This restart or reallocation of the ID can be problematic. That's where service comes to help here. A service actually groups a set of pods based on the functionality it exposes. So instead of calling a pod directly, we can define a service and then route the traffic or invoke that service, which will eventually route our calls into the right pods required. So depending on the replicas, you can have multiple pods installed, right? Or pod started. So service will ensure that, service will ensure that it gets load balanced and routed to one of the pods that actually implement the service. The way it implements that mechanism is through a label and a selector mechanism. So when we create a pod, we associate certain labels with that, which later the service uses to associate or group them together using that to form the service. So that's how it was. This also enables service discovery, because whenever we restart a pod, depending on the label, it actually associates that pod with the service. So that makes service discovery possible. And again, the service, in order to expose that to the outside world, outside the cluster, there is something called an egress. So if you look at a diagram, when I call is import, somebody reaches through egress to the service to the pod. That's how the routing would happen. This is a sample deployment spec. You can see, initially the time is deployment, and then max labels specifies the pods that this deployment loops into, and then this template is the pod template. You can see the label there, and then in the spec you can see the containers that it's going to start. So this is a sample deployment spec. And Kubernetes, these are the key components when we install Kubernetes that we deploy. One, the key or the core component is the API server, which exposes the Kubernetes API, which allows us to query and manipulate the Kubernetes API objects such as pod. And then controller manager, like we discussed about the controller, right? Deployer has a controller associated with that, which ensures the right number of replicas of pod run. And so there is a controller process associated with different types of workload resources, and by default there are several of them that ships with Kubernetes. So there is a process that hosts all of them, and that is what the controller manager is. And cloud controller manager is an optional component, but when it is Kubernetes is in the cloud, that component is what interacts with the cloud APIs and facilitates the infrastructure and communication with the cloud APIs. etcd is the data store, persistent data store, which actually stores the state of the Kubernetes cluster. It has everything like the objects created, the replicas, namespace, all those things comes in there. Kubelet runs at the node, and it ensures that the pod that we want to run at that node is actually, it receives a pod spec and spins off the pod in that, or runs the container based on that. Proxy deals with the networking and the service communication mechanism that we discussed earlier. Proxy is a key component in that, with the routing of the traffic to services. And scheduler, we saw that in the earlier session already. It makes sure whenever a new pod is created, it ensures that it gets a node to run on, and it gets the right node depending on the configurations. So those are the key components. So it just developed.
I think we need more interaction. So how many wants to run their application on Kubernetes? Basically. And how many wants to run clusters as well? Yeah, I think the answer is positive. So that means everyone wants to run their applications or wants to implement an ecosystem for Kubernetes. But the problem with that is, when you get started, it is too expensive in the sense we need more compute resources even to run the Kubernetes. Even if it is managed services from different cloud providers, or even if it is self-managed Kubernetes clusters. So if someone wants to play with Kubernetes, or if a developer wants to run their application, or start getting with the Kubernetes application development, we are having certain tools such as Minikube and Time, which will help us to run their applications, which is on the workstation. That means we can create a cluster of our own with certain specification which can run on the workstations. So there are two. Initially, it started with Minikube, but we are having a very good tool now called Time. Time is based out of Kubernetes in Docker. That is based out of a technology called Docker in Docker. DINT. So these are two amazing tools which we can easily run your Kubernetes clusters, even for the development or for SREs as well. So for an application developer, it is very much hard to pack their applications, because if you want to run the Kubernetes, if you want to run your application, for example, if it's a Java application, you may need certain export variables, you may need certain runtime configs, you may need a lot of things. So it is very, in terms of Kubernetes objects, it may can have deployment, it may can have services to export your service outside world. So there is a huge gap in that. So there is a need of packaging your entire application along with the Kubernetes manifestos. For that, we can use a tool called Helm. Helm is actually based off Golang. If you are aware about Golang development, you probably know about the certain packages from Golang. So it is based out of a text Golang package, which we can easily templatize our packaging of our applications into the Kubernetes. So it will be very helpful for HTML developers. And another thing is Customize. Customize is one of the native configuration management tool, which is actually based off of a protocol, not a protocol, a standard called JSON patch 6902. That means we can apply patches like edit, change, delete, everything on the JSON objects. Since Kubernetes objects are, when we are running our application, we mainly wrote the manifestos in Java or JSON format. So we can make use of customize to make your configuration more easier. But I would suggest, as a I've been into the platform engineering side, so I definitely suggest every platform engineer can use customize to make your configuration very easy, because I belongs to a team where we manage more than 40 clusters, which is self-managed. So and currently also it is self-managed. So the entire cluster is actually GitOps. We operated each and every clusters with the help of these customers. So I believe that it is very much helpful for the SRE people who can love to run, or GitOps. If you want to operate through the Git model of your clusters. So other than that, since for creating a Helm, or since we need to manage or attach or customize using the customized thing, there is a huge need of spending time on that each and every developer. So for making the developers' life more easier, we are having certain other tools such as Scaffold and Draft, which it will do a lot of magic at the back end. So you don't want to worry about anything if you use Draft. Draft is one of the best tools. So Draft is actually from Azure. So if you use Draft, you don't want to see anything about writing these manifestos, or most of the things which is usually managed by the DevOps guys. So you just want to focus on the application development, but the Draft simple commands from the Draft utility can help you to containerize and deploy the application code easily with the Kubernetes. So these are certain tools which can help and which will help the life more easier for the developers as well as the SREs. Thank you.
So we will go to an exciting topic. And Kubernetes, the real power is that it is very flexible. So extending Kubernetes, we can do at different dimensions. I think these are some of the key or high-level areas where we can extend Kubernetes. One is the kubectl binary. kubectl is the CLI tool for Kubernetes, which we use to interact with the control plane. So kubectl can take extensions or plugins to extend its functionality. We'll be going into details later, but that's one point. Then Kubernetes APIs. Access to the APIs can be it already comes with authentication and authorization mechanisms, but if you want to extend that, there are mechanisms for that by means of webhook. That is one other thing. And then we already saw some basic resources, right? Or one other thing. Some other things we already saw. If we want to extend that functionality, we want to add our custom resource. That's also possible. Then controllers, we saw one like the one for deployment, right? So we can have our own controllers too and deploy them. Then scheduler, which is what takes the code and deploy or assigns a node for that. If you want to customize that component, it is also possible. There is a scheduler framework also that came out where different points in the scheduling, decision making process we can customize using webhooks. And Kubernetes networking is another area. For example, if we want to encrypt down traffic or something like that, we can have network plugins installed. And storage, is what when the persistent volumes and that kind of storage. If you want to come up with something new kind of storage device, we can have plugins to actually adapt that into Kubernetes. So these are some of the key areas, and if you look at that, there are three main mechanisms by which these plugins can be installed in the Kubernetes. One is webhook, and all these mechanisms, one of these techniques will be used. It's either webhook or a binary plugin or a controller. Controller actually accesses Kubernetes APIs in order to do this functionality. So controller is going to be a client of Kubernetes API. Webhook, Kubernetes API is going to fall out. So Kubernetes API will be the client of the webhook, and binary plugin would run on kubelet. So it will be loaded by kubelet or kubectl. So those are the three different modes plugins will actually be loaded. So we'll just look at extending kubectl with binary plugin.
Thank you, Bridget, for giving the overview. So, as Bridget already told, the main good thing with Kubernetes is we can extend Kubernetes component. So that is what the different cloud providers extended Kubernetes into that way. They can customize. We can customize many of the things in Kubernetes. So, how many are aware of kubectl? A tool called kubectl. I am pretty sure that most of the people sitting here can about kubectl. So if someone is new to kubectl, so kubectl is the CLI tool. It is just a CLI tool. So it is a CLI tool which can be run as a binary in our systems, which can be used to interact with our clusters. So that is very simple, right? So it's a simple utility. But how many of you are aware about extending this Kubernetes plugins? Kubernetes kubectl with the help of writing the plugins. So there is a way to extend the capability of kubectl. If you go and see, if you type kubectl here, you can see a lot of things available. But think like I have logged as Jasmine user and PG have logged as PG user. And think like if we are having a capability in Kubernetes kubectl, in order to see who am I. That means in which user am I logged into the cluster. So that's a utility which is extending kubectl power, right? So that is what we are talking here. We can add complex behaviors of Kubernetes or Kubernetes ecosystem or the supporting activities which is needed for any organization or for any developers. So that means we can extend kubectl. And we can write this using very simple scripts even, and we can use any programming languages of to extend kubectl. And if someone is worried about the list of available plugins, you can see the list of available plugins using kubectl plugin list command. It's very easy that we can see the list of plugins available. There are already built around 200 plugins available in the kubectl extensions that can be found using this link. This is a repository for storing the plugins. So and also Crew is a tool which can help us to install any plugin. So it's a utility for help us to install plugins which is already available. And for the sake of demo, I have extended kubectl with the help of a plugin which I have written. You can find the source code. It is written in Golang. You can find the details of it from my public repo, that is kubectl breaking news. Don't think that it is extending the capability of Kubernetes, but it is just I'm a developer and I fed with a lot of workload activities which I suddenly I thought that I want to see what is happening outside the I want to see the breaking news from the kubectl itself. And I have written the plugin, to fetch the latest technology news from the outside world using the kubectl. Let me show that. I thought that I am okay with my trade. Everyone can hear. I'm not sure whether the demo will work because I have switched my personal system, but I will try. Okay. So you can see here. If you see here, I have queried for one of the plugins which is got installed. I hope everyone can see the screen. Okay, so you can see here the available list of plugins which is installed in this particular system, and one of that is breaking news. That is a plugin from my end I have installed here in this system. So I would like to see what is the breaking news. Yeah, you can see here, right? So I have extended the capability of the kubectl to see or to query the latest technology news since I have fed up with my lot of workloads. So this is how we can extend. This is not like extending Kubernetes, but this is what I'm trying to communicate, that we can extend kubectl in such a way that with our flexibilities. So you can see the source code from my public repo. It is for open source with Apache license. Let's see. I think he is supporting me.
So in this spec, we have a deployment name and the replicas, and in the status, available replicas, which means the number of replicas we requested is in the spec. Actual replicas will be stored in the available replicas. So the way we apply it is, apply this manifest file to create the custom resource definition, and in order to create, once that is done, we can create resources of this kind. This kind is foo. So foo kind we can create using this manifest on the right. So it's that simple manifest that comes in the custom resource definition here. It has two fields, a deployment name and replicas. So for the sample purpose, the way the CRD is used, it will track a deployment and make sure that the number of replicas specified is available or is configured for that deployment. That is what the sample deployment will do. So if you want to change the number of replicas, we can actually go through the CRD. Now, a CRD, that is, the data structure or the data associated with that resource. Now, it needs that logic, the controller logic, to ensure that the specification we requested is actually ensured. So, controller is going to be that piece of code that ensures that the spec or the desired state is actually maintained. So this is a custom controller which I took from the Kubernetes Components. It's a sample thing. I just wanted to mention two things. When we are writing Kubernetes client, API client, there is an SDK already provided, client Go, and this controller is also written using client Go. You can see that is what's in it's Golang. The source code is in Golang. How many of us are familiar with Golang? Yeah, if you are, but it's quite simple to read, right? If you're familiar with programming, it's like C, or you should be able to read it. And first one is the import sections, and the key things just wanted to mention. In here, we would connect to the Kubernetes API server in the first section, which is what it does by loading the configuration, which is the kubeconfig file. And then informer is another thing. When I said the controller actually ensures the desired state, the way it does is it actually keeps track of the changes or changes to that resources. So controller keeps track of the resource, the changes happens to all the changes that happens to that, and at every point it watches and checks if the desired state is actually met. If not, it has to take an action, right, to make sure that the desired state is met. In this case, the watching part is actually done by something called informer, shared informer. Kubernetes has a mechanism called watch, an API system called watch endpoint, and shared informer is the client-side implementation. It makes use of watch and maintains a cache of objects. So I'm just not going a lot into that. But first, in that first thing, that's what it was doing. It connected to the API server, and then the informer or the watch part was there. And if you look at the control definition, you can see the informer is being configured to install the event handlers. So it is specifically monitoring for those resources, in this case the deployment and the full resource that we create, the sample one. It is watching for changes to the full or the custom resource as well as the deployment in these two lines here. Okay. And when a change happens, it actually eventually goes on and checks. The case in our case was the number of replicas. So it's actually checking for the replicas here and updating deployment that is associated with it here. So this is the reconciliation loop or reconciliation logic where it actually ensures the right desired state is actually ensured. So we saw that we have a custom resource and a controller associated with that. So it's a typical pattern. Like whenever we define a custom resource, mostly there is going to be a controller associated with that to ensure something, right? So it's a pattern, and that pattern is right now here. It's called operator pattern. It's called operator because whenever we have a custom resource, it the controller logic actually would ensure the operational knowledge. For example, deployment, it has to be maintained in a certain way. So that's an operational knowledge that is maintained by humans usually, but it is embodied in this controller. So that's why it was called operator. Now we already saw a controller and a custom resource together. They can be called an operator, although it doesn't implement a lot of meaningful stuff here. We could have operators like take backups of systems when we have an upgrade and stuff like that. And there are already tools like KubeBuilder and Operator SDK which can actually generate the code for control and a CRD. So those are tools we can use to generate the code. And Operator and Helm chart also actually deploys things, but it looks similar in certain aspects. But what is different in Operator is that it has some operational knowledge. Helm chart mostly deals with the packaging and deployment. So that was one aspect in there. And we'll just take a look at the network plugins.
Thank you, Bridget. So before starting this topic, I want to know how got created the clusters using Kubernetes. Okay, I think it's a topic, especially to the cluster admins or mostly the SRE people. But we want to make sure that we are very much aware of network plugins because whatever things which we have mentioned in terms of extending the Kubernetes is not at all mandatory things. It can be added or it cannot be added. That is as per our recommendations of the organizations or policies of organization. But with respect to network plugins, even if it is an extension, this is like a cannot go without category extension. That means we must have to install or configure any of these network plugins for sure. If anyone got created a cluster using Kubernetes tool. It's a command line utility to create clusters, which is officially from the Kubernetes project. So if you created, you're pretty sure, you're wondering that why I'm not able to get deploy these pods, because definitely when you created a cluster, it will props for the network plugins. It will definitely look where is my network plugin. It will, each and every Kubernetes having certain directories, that is binary CNI binary directories and certain configuration directory. It will always, when you got installed, it will always look for these network plugins. You must have to install. So definitely we are going to make sure that we are aware about this kind of network plugins. There are two categories in that. First one is the CNN plugins and second one is the QNet. We should mostly talking about and aware about CNN plugins, because most of these CNN plugin will only enable the cross-node networking. So basically, everyone knows about the basic networking fundamentals of Kubernetes. What exactly we need the networking plugins in Kubernetes. There are mainly four things. We need C2C networking, that means container to container networking. We need port to port networking. We need to expose port to services, that means port to service and service to the external. So even if your code is shared, deployed, we want to make sure that this kind of plugins are installed, otherwise we cannot let our applications to be accessed from the outside. So these network plugins will certainly do main two things. First one, it will configure the network, then it will configure the routing. So these are the two basic fundamentals of the network plugins, especially the CNN plugins. So CNN plugin is nothing, it's it will follows the container network interface specification. That is standard. That is a common standard. I think it's from Open Container Initiative, or it may be a separated specification or standard, but every of these CNN plugins is following these standards in order to enable the networking in Kubernetes. So basically, it support host port. That means we can even talk with the loopback addresses of the nodes where the pod is running. Other one is the traffic shaping. I think traffic shaping is one of the best known topic for developers, especially because they may need to tweak how the traffic is getting ingressed or egressed. That means getting out to the cluster and into the cluster. So we can make use of these network plugins to make this kind of traffic shaping as well. And I like to share a few of the commonly and widely used network plugins such as Calico. I'm pretty sure that everybody's heard about Calico. Calico is a very wonderful network plugin. It is having a lot of extensions. VNet is one of the other commonly used one. Other one is Plan, and finally Spec for simplicity. And there are new things. One is called Cilium and other one is Anglia. That is basically from the VMware Anglia. So I'd like to share one more insight here. Basically, Calico or any of the Kubernetes plugin by default, it uses the kube proxy, and it will make IP tables routing rules to be created on the behind the scenes when you got created a service. That means it should be routed, as I already told, we need to let the port to be routed to the service. So this kind of routing rules will be happened with the help of these IP tables. And this network plugins will take care of creating that rules for us, because it is nearly impossible for a human being to write this kind of routing rules every time we are creating these services. So that is what it is famous and good for. But we are having a new thing as well called eBPF, that is extended Berkeley's packet filter. We can let eBPF modules to be route our routings. That means instead of using the IP tables, we can make use of eBPF. It's a packet filter tool which is mostly in the Linux boxes. So the Cilium is famous for that. Basically, Cilium let their routing happen through that routing happen through the eBPF filter. The good thing with that is, it is not making any rules. Instead, it is writing this routing in the kernel space. That means it is directly tweaking the data path in the kernel with the help of some sandbox programs. So this is much introduction to the network plugins. I hope we have completed. Yes, we have completed